So just leading on from proportions, and then, so we'll go over direct proportions, which was the new thing that I introduced last time. Do you remember?
Yes, I remember.
Yeah, and then if you're finding that okay, we'll move on to, we might have a look at this inverse proportion, which is exactly the same, but the opposite.
Yes.
Did you have a little look in your workbook? Did you find this in your workbook, or?
I looked and I couldn't really find it. There was only just, yes.
That's okay. It was just in case it wasn't in your book, but
yeah.
Because this is more towards the what you do at GCSE, but I just figured since you were doing so well with proportions, I might as well teach you the whole lot while we're still on the topic.
Okay, yeah.
Okay, so I'll just get rid of this for a sec. I don't know if you remember last time, direct proportion was all about when things were proportional.
Yes.
And that was similar to ratios in the sense that it was all about things being multiples of each other.
Yeah.
So for example, if I had a ratio 3 to 9,
yes.
No, that's a bad one, 3 to 7, let's do 3 to 7. That is proportional to if the ratio was 15 to 21.
Yeah, because you have to multiply them by the same number.
Yeah, what is that same number, do you know?
3, no, wait.
Oh no, wait, I've wrote that wrong.
Yeah,
That's me.
wrong, because it's going to be 5.
Yeah, 35.
5.
That was me trying to do two things at once there.
Yeah.
But yeah, good spot. So yeah, so this one is proportional to this one because they both have this common multiple.
Yeah.
Likewise, we did it with fractions. Say that I had 2/5. That would be proportional to, I'll try and get it right this time, 16/40.
Yeah.
Yeah? What is the multiple there? What am I times it by?
Multiplying by 4.
No, by 4.
5. No, by 8.
By 8, yeah, brilliant. Really good. So those two things are proportional. And in those cases, we call this direct proportion. If we were to draw it on a graph, we would get a straight line through the origin. Those are the two key points. You don't necessarily need to remember this. This is just like something that might be useful to know. So we'll start off just having a look at these questions first. So I've got 4 questions.
Yes.
And we'll just see if we can remember the method. I'll help you through.
Okay. Y is directly proportional to x when x equals 15, y equals 35, y when x equals 40. Okay.
Do you remember how we did this one?
Yes. Okay, so y.
Yeah.
X.
Y is directly proportional to x.
15y equals 30. Okay, so 15 times 2. And x is 20. 20.
So when the next line that we write, do you remember? We replace the
K.
proportional sign with a K, yeah?
Yeah.
Then we substitute these in. I think have you already done it?
Yeah.
Do you know what K is?
Yeah. Yes, K is 30 equals 15 and 14 equals to 20. K equals to 20.
So K equals 2 when I rearrange that.
2.
And then if I sub that back into there, Y equals 2 times X.
Yeah, because you see K will equal to 2 because you see the 15. 15 multiplied by 2.
Yeah. So what will Y equal when X is 40 then?
Y. Okay, Okay, how's that work? 15y equals to 30. 1. No.
So when x equals 40,
30.
we can substitute that into this equation.
Yeah, x equals 2.
So
20. Yeah, y 2 multiplied by 40, which is 80.
yeah, so then y equals 80. Does that make sense?
Yeah. So okay. So is this how it went? So 15y equals 30. So 15
Yeah.
times 2 equals 30, and then you can divide it by 40 by 2, and you get 20, and then you know that k is 2 because you divided it and multiplied it, and then after.
Did you get the y and the x the right way around? X is 15 and y is 30.
Oh, x equals 15 and y.
So then we get the k is 2.
Yeah, because
But yeah,
multiplied by 2 is 30. Yeah.
likewise, if you wanted to do this question, you could then say, what is x? Hang on, I'll just type it. X when y is 35, let's say.
Yeah. Let me scroll
I just wrote it next to it in pink.
down. Okay, yeah. What is x when y is 35? That would be what is x? X will be equal to 35. 120.
Not quite. So we know that y is 35. So we replace the y in this equation with 35.
Yeah.
So I write it like this. 35 equals 2 times x.
Yeah.
So then, to rearrange this to get x equals,
Yeah, we need to do
we need to do the opposite. So it's being times on this side.
and then you need to divide it.
You need to divide both sides. So what's x going to be?
2. We will divide 35 by 2. X will be equal to
X will be equal to 35 divided by 2.
17.5.
Yeah,
Let me wait. 30.
yeah, no problem.
Yeah, I got 17.5. Yeah. 17.5. Okay, next one. The distance fell d of a freely floating body varies differently. T is the ground. When d equals 3 and t equals 1.2,
Yeah.
find d when t equals to 2. Okay.
So again, do the exact same steps. D is directly proportional to t
Yeah. So
when, yeah.
yeah, and then you got to do the,
And then what do I write?
and then you do t equals. We want to t.
So that's a good point actually. So it's really important that you write it the right way around. So do you remember when we did ratios? And if it said the ratio of money that Sally and Harry have, you have to write the numbers the same way around, otherwise.
So d equals d because
Yeah, so D equals K times T.
D equals k times 2, and then k times k2.
So now, so we've got this D equals KT. Are you happy up to here?
Yeah.
Yeah? And then we've got two pieces of information that we can substitute into the equation where D and T is. So we put where D is, the 3, we put where t is, the 1.2. And now we get 3 equals k times 1.2.
Yeah, because 3, okay, 1 second, D, okay. So,
Yeah, does that make sense?
Yeah.
So this is quite a tricky one if you don't have a calculator. Do you have a calculator? No? So we'll have to convert this to a fraction, but it's still doable.
Okay.
So to get k, what do I have to do now?
You need to do the divided
Divided by,
by 2. X. Wait.
this is a multiplication, not an x.
Oh, divided by 2.
Sorry,
T.
divided by 1.2.
Divide. Three. Divide both sides. So 3.
Both sides, yeah. So on the one side, we get just k, and on the other side, we get 3 divided by 1.2.
Yeah.
1.2 is a fraction, is 6/5, is it? Yeah. 6/5. So how do we do this then?
You can divide it.
How do we divide by fractions?
The top. The top.
Yeah, the top. What do we do with it?
You multiply that. Yeah.
Nearly, very close.
Divide it.
So we don't just divide the top and divide the bottom. We have to do something first.
Oh,
We-
then you simplify.
Not quite. Good guess though. We have to flip this round. So we can't ever divide by fractions. We can only times.
Okay. So.
But we know that if we flip this, it's the same as being divided.
So 5/6.
Yeah, so we, instead of dividing by 6/5, we times by 5/6,
So 15
which gives us 15 over
18.
18.
Yeah.
6/5. And then can we simplify this?
Yes. Yeah. By
What is it? What goes into it?
3 can go.
3 can go, and then we get 5/6.
6. 5/6. Yeah, and we got it the same at the start.
Wait, does that make sense? 3 divided by 6/5.
We got our original answer.
Yeah, that's what I'm thinking. That seems strange. Maybe I'm having a bit of a slow day in my brain. Divide by 1.2. 1.2 is 6/5. Oh, it's me being silly. Right, do you want to see what happened?
Yeah.
So I should have wrote this like this.
Yeah.
Yeah.
Because
Yeah.
when it's
And then you times the top and times the bottom.
Yeah, because if you want to divide, you've got to do the
Yeah. But we can still divide this by 3 to simplify it. So
Yeah.
what do we get?
3. Wait, we still have this 15/6.
Yeah. So we do 3 times 5 is 15.
5/2.
5/2. Brilliant. And that's what k is?
Yeah, K is equals, yeah. 5
Yeah.
over 2.
So I'll just move this question down a little bit. So we then rewrite the equation because now we know what K is, so we don't have to just use K. So we can write that D is equal to 5 over 2 times T.
Yeah.
Yeah? Find D. So then the actual question is find D when T equals 2.
So first you got to do T, you got to divide.
So
T equals to 2. T equals to 2.
yeah.
2, and then what you got to do, you got to divide it by, yeah, you got to divide it by, we need to get the equivalent, the fraction to do
So we substitute T equals 2 into this equation,
it. Yeah,
which gets us 5 over 2 times 2,
yeah.
which gets us 10 over 2,
Yeah, 10 over 2.
which is simplified.
Yeah, simplify. Yeah, 5 over 1.
5 over 1, yeah, brilliant. Or just 5, we can write that as.
Yeah.
Okay, excellent. Now, can we find T when D equals 7?
Yes.
Yeah, hope so.
Okay, so T.
I'll just move them. So T equals, D equals 7 even. Yeah. And that is equal to 5 over 2 times T.
Wait, 5 over 2. Okay, so, and then 5 over, I have one question.
Yeah, of course.
Say yeah, if it was a question, and from our, say we got 5 over 2, this one, yeah, and we do like the very first question of this, the fraction that we get, we will always use it.
Yeah, we will always use it because it's like as if when you scroll all the way to the top of the page, we might have a graph that looks like y equals 5 over 2x.
Yeah.
And it might look like that. And all we're doing is we're saying, right, when x equals, I know that they use d and t, but when x equals 2, let's say that that's here.
Yeah.
All we're doing is using this line to find out what y is when x equals 2.
Yeah. So okay.
Yeah?
So
So then, if we said when y is 10, what's x? We can do the same. By substituting 10 in, all we're doing is finding what x is. And that's because this is the gradient of the graph. K is. Have you done gradients yet?
yeah.
Like y equals mx plus c? Yeah? Does that make sense? Is that kind of, or has that made you more unsure? More unsure or less confident?
Just a bit though.
We'll finish this question and then I'll try and explain that again better.
Okay.
But yeah, we always use the same k value because that's the multiple.
Okay.
Actually, you know what might be a better way to explain it? You remember when we did this one? The ratios one?
Yes.
At the beginning. And we said that this one was times 5 and this was times 8.
Yes.
That is the k value for these. That is like their multiple of direct proportionality.
Okay.
And that's all we're saying for these ones is that there's 5/2 different. For example, if we had what's the best way? Does that make sense? Basically, the answer is yes. We always use the same k value.
Okay. The method is too. It's a bit too hard a bit.
This method, yeah, that we've been doing in the blue and pink.
Yeah, because it's like a long so you got to find so the proportional two, and then d equals kt, and then those bits are easy. And then when you start for this one, 3 equals kx, no, k multiplied by 1.2. Yeah, and then divide it by 1.2. Okay, let's.
Should we go over it from the top again? Yeah? Okay. Sometimes, like, it even happens to me now. I'm still at university now, and when I learn hard things, sometimes I just need to do it a few times before I understand. I definitely don't understand things the first time, so I don't expect you to understand things the first time. Just rub all this out. Right. Okay. Oh, that's so weird. Do you see that? I could pick the rubbing out up.
Yeah.
I wonder if an easier way to do this is just to move that. What I always say about this online thing is that you can tell that whoever designed it has never needed to use something like this.
Yeah.
Actually, right. This isn't working the way that I wanted to. I'll start a new page. Right. The distance fell of a freely falling body varies directly as the time t of the object hits the ground.
Yes. Okay, so
D is
equal to kt.
Yeah, is directly proportional to t.
Yeah. And then
Do you happen to know an equation that links distance and time together?
like d equals to kt.
Yeah, similar to d equals to kt, but can you think of an equation that has distance and time in? Really famous equation.
With numbers or just
With letters, just like in physics. You might have done it in physics.
F equals to F equals to K.
Yeah, you're thinking of F equals ma, aren't you?
Yeah.
Force is mass times acceleration. So let's take that for an example. We'll just detour for a little bit. F equals ma. This looks a lot like this, doesn't it?
Yeah.
D equals kt. So what we know that force is directly proportional to acceleration.
Yes.
Because when we rewrite that, the k is actually equal to the mass of the particle.
Okay.
Yeah? So likewise, a famous equation relating distance and time that you might have heard of is speed equals distance divided by time.
Okay. So if it gave us F equals ma. So we'll do, so m is the k.
Yeah, m is the k.
So you will do f equals, it is proportional to a, and then you do
Yeah.
the equals sign, and then f equals ka.
Yeah,
Well, where did you get the k from here?
from here.
Yeah, but so you just got a random.
I'm just showing you like that this f equals ma is a formula that we use in real life. Yeah, it's like a real one of Newton's laws, Isaac Newton's laws of motion. And that shows that there's two things that are directly proportional to f within that.
Okay, so
This hasn't got anything to do with the question. This is just, we could also write it like this. Force is proportional to the mass.
okay, so say there was a question like
Yeah.
like D equals to F.
Yeah.
Yeah, and then what we would do, we would on the bottom we would do D equals to K F.
Yeah.
And then the arrow sign to F, and then
Yeah.
is that good? So yeah.
Yeah. So if D was proportional to F, if D was directly proportional to F, we would rewrite that as equals KF. D equals KF, where K is some constant times by F. K is just a number.
So you can use any letter for K.
Yeah, any letter, yeah. If we know the letter, if we know, for example, that K is 10, then we could replace that by 10, or we could replace that by M if we knew that K was equal to M.
Okay. So
For example, if I just use that F equals MA for a second, and I say that F is equal to KA,
yes.
where F is acceleration. The force is 15 newtons with an acceleration of 10 meters per second squared.
Yes. F equals K, where F is force, is 15, and okay.